Right, so last lesson, happily ending the series. No? Yes. I'm happily ending. Right, so yes, we have studied about these information systems, starting from the data information and what the systems are. There is various types of examples of the system, and just we move into how does these organizations are using systems. So there are different strategies. So in order to support these strategies, yes, these various systems we are using it. So about the strategies and systems we have discussed, then we move into this infrastructure. If we need to implement a system, what we need. So what would be this backbone? So the hardware, the software, so a little bit of that we have discussed here. And we move into these enterprise applications. So information systems, and this is going to be a special kind of information system because these systems the entire organization can use. All the divisions will be accessing the same system, or different level of employees also will be accessing the same system. So we will discuss about this CRM, SCM, can you remember these names? Then what else? CRM, SCM, and you told you remember, that's why I'm asking. Remember that was number here. You told me, remember here. Just correct him and another one. PRP or the enterprise system. So about these four, the enterprise applications. So about their functions, the benefits, where we can use them, and related to that, the cost or the challenges, why the systems could go failure. So those things also we were discussing. And just then we move into this e-commerce. So yes, information system or one of the major use they will be using e-commerce because in order to run the e-commerce or e-business, information systems are going to be a must. So the different types of e-commerce, different models, then the advantage, disadvantage, all things we are discussing. And we all need a individual activity also there. As I know, one person has not submitted. Who is that one person? එයා වෙත් නෑ ආයෙත් submit කරන්න ඕනේද නැද්ද කියලා. Anyone here haven't submitted the individual activity? You didn't submit? Because if you are going to miss the assignments, do you know what happens? You can do an alternative, but you will be getting only the pass mark. So if you miss an assignment, yes, we give an alternative. But ඉස්සර ගත්ත ඔක්කොම ටික නැති වෙනවා. Only the 20 marks you will be getting. So that's why I'm just checking if. So before going to the exam division and coming from Ms. Sashara, you have to try to finish them off. Or else only the pass mark will be given. Let's quickly check before moving on. Yes, only 57 submitted. There are 58, right? 58 neda. Coordinator. Isn't it? Um, yeah, so HKJC Fernando. Janik Fernando. Online. So can you just pass the message, Puta, saying HKJC Fernando has not submitted the individual report, but for the presentation and the quiz also has been done. So just pass the message if we done it. He needs to do that to contact me to send me an email. Else I will send the marks. Then it will be alternative and only 20 marks. Okay. With that, yeah, only all the others have. And the individual quiz. So that also, yes, again, I think one person hasn't done. Why? ඒකත් ඔයගලන් ඔයලා එන්නේ නැහැ. අපිම හොයලා බලන්න ඕනේ නේ. So it's Asif. In Asif. Hasif. Number 27. It's only the name is there. N. Online. So, but he also has participated to the presentation and the individual report. Not done the individual quiz. So again, an excuse could be given, but ask them to Asif also, Buddha, N Asif, number 27. So ask them to contact me within tomorrow. Just send me an email. Then I can make some alternative options. Else can't help. Yeah. All the others have done. So did you check your marks? Good. Need more marks? Or less marks? Fine. So ask those two to send me an email within tomorrow. Because I will read, so I will need to do one presentation. So I can send them out. Then they will be getting alternative and only 20 marks. Right. So then today, let's after the e-commerce, we are again moving to discuss about the databases. So this should have been come under or maybe near with this infrastructure. So where we know we need the hardware, we need the software, then the network, and people also needed in order to build and in order to use. And at the same time, the data is going to be another major or the important resource in this data, in this information system. So managing the data, so how we are going to do this database data resource management. So basics we should be knowing. So this will be our learning objectives for today's session. So we will be getting to know before databases how these organizations were saving data. So can you find what method or what approach they were using before databases? Yeah, so the traditional file environment, we can say they were using the files in order to save the data. So we will be getting to know a little bit what are the issues in this traditional file environment. Then just we will move into the databases. So today or nowadays how these organizations are using this database approach. Then in order to develop these databases and in order to maintain these databases, we use an information system. What is that information system? Yeah. Okay, a common name we are giving for these systems to develop the databases and maintain. Access, yes, correct. So that is the specific name. What is the common name? Yeah, the DBMS, the database management system. So we will be using a database management system. Could be an access or could be this MySQL, so the different ones are there in order to develop, maintain these databases. And yeah. Then yes, we will be discussing about the process of designing the databases. So little bit the basics. So we are not going to go for practical or depth on developing, but the steps little bit we will be getting to know. So data resource management, why it is important, as we were saying, in the information system, the input is going to be the data. So if we need this very quality information, where we will be getting the support in order to take the decisions or in order to make the strategies and everything. First of all, the data is important. So in an organization, maintaining this data is a very important thing. So it could be about the internal data or even the external data about the stakeholders or about the market. So all this data we need to save or store and keep in a proper way. Then only whenever needed or whatever information we needed, in an easy way or maybe in an efficient way, we will be able to generate it. So if we have stored and kept our data in a proper way, in an organized, in a structured way, then it's going to be easy for us to access the data easy or to retract to get the data back whenever needed, and using that data to process them properly. So whatever information we are going to process, so we will be having all the data. So properly we will be able to in an efficient way process and generate the needful information. So overall managing our information in the organization, which will be supporting us in order to take the decisions, will be easy for us. So that's why data resource management is going to be important. So we are saying in a structured way or maybe in a proper way, organized way, we have to save the data. So if we see how we can do this in an organization or in a database, how we can in a structured way save the data. So before moving to database, let's see if you are going to come up with a report. So you follow maybe the PowerPoint and insert the and the report. So let's assume you are going to come up with a report, or for your business finance, you came up with a report. So yes, you was creating. So how did you start? Very first thing what you did. Okay. So the homework done, preparation done, and now you are ready. So now you are going to type the report. Then how did you start typing the report? So now you have put them in the report. How did you start? Okay, yes, in a Word document. What is the topic? Any topic you have? Some people legalize it. I didn't know what it is. So let's assume digital twin. Then how did you start to type digital twin? What is it? A very simple way. Just tell me how you are going to start type digital twin. Introduction. Yes. So if you need to type the introduction, yes, we need the letter. What letters we need? So we have to type the introduction. What are the spellings? So we are starting with that. Or we can say the letters we are starting. So all the background done here. So now we are putting them to the report. Then you can submit. Yeah, with INTRODUCTION, you are starting. So once you put these letters together, so we know the letters. But if you're going to put put them in a jumble I, B, U, C, E, then with the we will be getting the full word? No. So just letters we are going to put them together, but they need to be in the specific or the correct order. Then the needful words, the correct words are coming out. Then what you are doing? You are collecting the words together, putting the words together, and you are creating sentences. So again, they should be in the correct way or the logical way. So in the school days, we have studied that object, verb, so then only the proper sentences are coming up. Then when sentences are getting together, it's going to be a paragraph. So yes, then you come up with paragraph. So when you are defining or when you are breaking the paragraph, there is a logic or there should be some relationship there. You can make a part of a full report, 20 pages, one big paragraph. Yeah, it could not be. So we know maybe very small paragraphs in a readable way. We are putting them again in the proper order. So if introduction comes in the end, what will happen? Mr. Charlie will reduce you the mark. Right, so they should be in a logical way, in a proper flow, they should be moving on. So yeah, in the proper way, we are putting this paragraph. Then yes, at the end, we will be coming with the document. So maybe starting from these letters, but we are ending in a big report or in a big document where we are putting them all in a proper way, or maybe we can say we are in a relatable way, in a logical way we are organizing. That just is pretty good report is there. Same with the data. Yes, we are going to store them, but this database is not a warehouse or not a storage room or storeroom. They are in a proper way. We have to save and keep the data. So in a computer, if we say we are saving data, in what form we will be saving? Computers, we are saving the data. What do you think the very basic unit? Bits. We are starting from the bits. So when we say bit, it will be a yeah, so bit will be a 0 or 1. So 0 or 1 could be a bit. Then when these bits get together only, bytes are coming. So how many bits needs to get together? 8 bits together. Yes, we will be coming with a byte. So this byte, we can say it's yes. What's your input to that? Yes, 1024 bit will be a K, a kilo byte. Yeah, it's correct. But 8 bits together will be 1 byte. So this 1 byte, we will be needing 1, or maybe we will be needing 1 byte to save a character. So if you are going to save a character, just we will be needing 1 byte or 8 bits. So when we say character, what it is? It could be a letter, ABC letters, or even a number, 1, 2, 3 could be, even a symbol, anything could be. So that's what we are referring as a character. So in order to save a character, just we will be needing this box. Then if we come from that end now, just we add the bits, then from bits we have formulated the bytes, and that means this character. So if we are going to put these bits together, bytes together, so 2, 3 bytes together, what we will be able to do, we will be able to formulate the word, or we will be able to come up with the word. So let's assume we are going to formulate a word, say, right, so we have the bits. It could be 0 or a 1. Then we are moving to bytes. So that means 8 bits together. Or that will be a character, or a letter, or a number, or a symbol could be. So now we are going to put these characters together. So let's assume I'm putting these four characters together. So what I have formulated? A verb. Yes, so maybe name. Then maybe I can formulate another verb, some other characters together. Age. So these are verbs. Normally these are verbs, but when it comes to database, how we are referring them, we call them as fields. So name will be a field. So under the name field, I'm going to enter all your names. Or under the field age, I'm going to enter all your age or the date of birth. Those things I'm going to enter. So bytes together will be formulating fields. Then, if you are going to put these fields together, what we will be able to come up with? So let's assume your name, age, likewise some relatable fields I'm going to put together. Then what I will be coming with? We can consider it as a record. So if I get one record about a student, so I have student number 1, the name and their age, their address. So it's going to be a record. Likewise, I can go to the second record. So it could be the student number 2, their name, their age, address. So those records are there. So when relatable fields are put in together, we will be able to formulate or we will be coming up with records. Okay, so likewise, we have many records for student number 1, 2, 3. We have many records. Then, if I am going to consider all these records together, then what it's going to be? All the records together, we call it a file. So maybe this could be the personal detail file. So we have a file with the personal details. Likewise, maybe with your results, we are adding another file. So that's why we'll be adding relatable information, your name, subject, your CA marks, CSC marks, the grade could be. And maybe we can have another file with the finance related details. So there's another file with all your finance related details. So likewise, these relatable records together, we are coming with files. Then, when all these files are put in together, what does it going to be? It is going to be a database. So all the files together, we will be saying that will be the database. So in the database also, there should be relatable files. So if you take a SAP database, yes, this student's personal information, student's exam related information, or the student's finance related information should be there, or even could be the lecturer related details could be there. But in our SAP database, are we going to have a file related to maybe slip information? Students? No. So we get the idea. Just in the database, the relatable files will be there. So starting from with bytes, then we are moving to fields, then fields together records. All these relatable records will be different files, and when we consider or when we connect all these files, that is going to be the database. So what we were discussing, it's there in the slides too, and this diagram is also there. So you can have a look. So we are starting from bit, then 8 bits together will be a byte. Then just these bytes together, we can create a word, that means a field. So they are taken as course. Course is a field. Then relatable fields together. So student ID is a field, course, date, grade. So these relatable fields together will be a record. Likewise, when we have many records together, the relatable records together will be a file. So course file. Likewise, yes, we can have many files, relatable files. So could be the course file, personal file, and the financial file. So all these connected together will be the database. So this will be the logic or the hierarchy how this data is being saved in a database. So yes, this is the database. So the basic idea we have. So I said before, now organizations are using the database. But before moving to database, what was the way they were using? Yeah, so they could be the physical files, or even they could be these electronic files. Could be, but separately if you are maintaining the folders of files separately, then it's still the traditional file environment. So always it may not be the physical file. This could be the hard copies, even could be the soft copies. But if you are having these separate Excel sheets, yeah, it's moment, or maybe even the folders we may be adding if you are not connecting all these files together. So let's see how or maybe what is traditional file processing is. So yes, as we know, it's also here like same. So if you take a physical one, yes, we know the hard copies are there. Even in an electronic format could be there. So we will be having the bits, bytes, files, but field, record, and file also. But what is the change? These files may not be connected with each other. Separately, we are adding the file. So maybe Miss Jennifer is maintaining your personal information file, and registrar, so Mr. Ishar is maintaining your exam related file, and Ms. Kokia will be maintaining your finance related file. So separately they have the information, the data, and they keep maintaining. There's no any one point to connect all these files together. So in the traditional file environment also could be an e-format or soft copies, but what's going to happen is we are starting from the file. So independent, separate files, for each and every need, or maybe each and every user will be using. So that will be the traditional file approach. And if you are going to connect these files only, it's going to be the database. So what do you think the issues of this file approach? Separate independent files, each and every person maintaining for their own need. What kind of issues we may be facing? Problems. Data might get lost. Yes, could be. Definitely space, because why? The data is going to get duplicated. Because if we take here, there could be the name field. So what will happen? This data is also adding your name. Again, Miss Kokila or Miss Ishara, everyone is having your name. So duplication. Because of this duplication, definitely the space issues are there. And with the duplication, what other issue could happen? If a data is getting duplicated in many places. Reliability issue is there definitely. So let's assume you gave your email addresses and it has been updated in all the places when you are joining. In between, what happens? You change your email address. You cannot cover. Yeah, you all do not do because you may have a nice professional email, but when it comes to students who are coming after A-levels, I will take a nice email. Contact me. How many rows? Here and not clearly they come. Or some with their parents' email address. In the registration form they are giving, so they may not have an email ID. Email addresses. So we also update and keep them. Then after coming to the first semester only, they get to know, okay, we have to go with the professional email ID or we need an email ID. They are changing and they come and tell us. But usually what's happening? This information goes to Miss Jennifer. Then Miss Jennifer is updating. But sometimes what happens? Others have not updated. So still we may be sending emails to Papala and Ampala, or maybe for a funny email address. And now maybe the student is not checking that also. They have changed the email address. So reliability issues definitely there because the data consistency may not be there. Inconsistency will be there. In different places, different data could be there. So when updating the data, these issues could up. Any other problem? Definitely, when we are going to do a process, it's going to get time consuming. So if we need to find, so maybe Ms. Ishara, before allowing you to sit for the exam, are they checking attendance? Yes. So 80%. You all have for MIS. Right, so I don't know that you have to Mr. Ishara to register we don't know about that. Okay, so what will happen? But yes, they have to find your attendance in a simple way we think. But do they have those information? No. Those all these attendance related information are with Miss Jennifer. So maybe they have to send an email or they have to go and ask. Then they will be doing the calculations and again the email says the attachment or in a physical manual way. We have to change the pass the useful information. So yes, it's going to be time consuming to retrieve the data or to generate, do the process and to generate the useful information. And means that maybe one student data could be get lost or maybe mistakenly we can type in 20% data intensity and 80% කියලා වැටෙන්න පුළුවන්. ඒකට student කියන්නේ නැහැ. අනිත් පැත්තට ආවම කමන්නේ student running and coming and saying, oh no, I came to all the classes, MIS classes, I didn't miss any. You came 100%? Wow, good. So yeah, they may be saying. So these things also could happen. These mistakes also, these errors also could happen when this data is in different phases, because the data not only integration between the data, not only links between the data. So in order to process it, yes, it's going to be really hard. So some of the issues, yes, we have put here. We call the data redundancy, that is the duplication of data. So as you can see, because of that, updating issues, inconsistency issues are there. Then no integration, so different separately we are in the data. So when we need to process the information or to complete the activity process, generate information, yes, it's going to get time, difficult and the issues, and the data dependence. So maybe different users maintaining data in separate format. So maybe I'm adding an Excel sheet. Another person may be adding in a Word document, or another person just in a text document, or even the systems could be different format. So data will be getting dependent according to each and every user, or according to each and every software, hardware. Also the system also could be. And there could be data lack of integrity and lack of standardization. So because what could happen? Sometimes this data may be maintaining your full name, but in the exam division there could be only maintaining your maybe division, or maybe now we are maintaining. Maybe your first name and the last name we are maintaining. So now when we are going to send the results, the CA marks or something, or the results, what's going to happen? There could be issues because there is no any proper standard. So if there are any 2-3 people with the same initials and maybe the surnames, then just those are going to be issues. So these kind of issues also could happen because there is no any standard. According to each and every user, according to our need, we may be maintaining the data. So because of these issues on leaving this traditional file environment in order to save the data, organizations have moved into this database management tactics. As we already know what database is, what's going to happen? Yes, we have the data in separate files, but now we are going to connect them all and put it in one place. Then it's going to be the database. Then in order to develop this database, or in order to maintain the database, to use the database, yes, we are using the database management system, DBMS. So this diagram also gives us an idea. So maybe in an organization, even could be different systems we are using, but we can get connected to one database. So this is an example of a bank. So there is this checking account program, a separate activity process, or the savings account, the installment loan program. But what they are doing, all are getting connected to one customer database. So it could be the customer personal details. It's needed for all the other the installment or to the savings account programs too. But they no need to get duplicated. The same data we will be accessing. So if we are upgrading, or maybe if we need to update also, we are going to update the database. Common one. So now whoever accesses later on will be able to see the updated version of the data. So it could be different even applications or different systems, but we will be able to access the same customer or the same database through database management system. So let's then move into this DBMS. Right. So using the DBMS, we can do 3 activities. So basically 3 things we can do. What are they? Yes. What we can do? That's correct. We can create database there. Yes, using DBMS, we can create the database. What is the second function we can do. Yes, we can maintain the databases. Then, yeah, so create tool, maintaining also tool. What's the third function we can? Yes, we can use the database through these DBMS. So these three are going to be the major three functions which we will be able to do through an DBMS. So creating a database and the relevant interface. So when we say database, it's going to be the backend, how we are going to store and keep the data. So we users may not see the database directly. We need an interface, so maybe a form where we will be entering the useful information and submit, where we will be going and getting saved. Or when we need to retrieve the data, maybe we need a report kind of an interface where we will be able to see all your information. So those interfaces also, the database and the relevant applications we will be able to develop using the DBMS, and we can maintain the database also via or through this DBMS. And the main part to use. So we are not going to just store and keep the data. We are going to get that data and use the data. So in order to use the data also, yes, we will be using this database management system. So we already know about these databases, how the database is being formulated. So if we need to give a nice definition, what we can say. So database, yes, we can say it's a shared collection of logically related data. So that word is important. So here we are saying we are going to connect or put all the files together, but it should be in a logical way or maybe in a relatable way it should be. So that word is really important when we are talking about the databases. We are not going to just store the data or save the data, but in a logical way, in a structured, organized way, we are going to store the data. So we will be saving the data and even the description of a database, or we call it as the data dictionary also, in the DBMS we will be maintaining in order to get to know about the data. Right. So in the databases, there are three concepts we need to know. So one, we are referring as the entity. So from this hierarchy, what could be an entity? So can you figure it? So entities in a database, we can say maybe, so if we take here, we are saying we are going to store data related to students. So student we consider as an entity. That means a person or could be a place or even could be lecture hall. So we are going to say details information about the lecture halls, how many lecture halls, what other facilities we have. So the lecture hall could be an entity, or even could be an exam, a process. So related to your exams examinations, we can consider as an entity. So if you are taking the student, right? So we are having information related to student. It's going to be an entity. Then, in or maybe related to this entity, we will be saving relatable data or the properties of this student. Those we are calling as attributes. So in the database about students, we are going to store the data. Then what data we will be storing? Yes, shall we start? Can you tell me an attribute of a student? What data we may be needing to save? Yeah, so if you how does have to give an answer. So if you say personal details, specific, exactly, an example. Yeah, we can take name. Yeah, everyone get ready. An attribute of student. Yes, we can have name. Yeah, when we say age, what is better to say the age or the date of birthday, because age ना पास आपने update कराना है birthday की बार उन्होंने लोगों ने update कराया yeah so no any birthdays in your class अगर birthday celebrate करना है या family को हमारे birthday celebrate करना अपना cake Oh, you will this? Honey, you discuss how they take up then. Yes. They are so good. They give us cake, biscuit. I think of asking on number I have gone in the first class. Then each and every day you also have brought me some. Yes? Don't? Yes, gave. Those students gave. BK students brought even one number. Okay, so DOB. Here's the registration number, correct? Gender, then non-genders, dagana samaru. Yes. Yeah, definitely the address is needed. Yeah. Contact number. Yeah, we can say the contact number. Yes. Qualifications level all over that. Okay, could be academic information. Yeah, so be ready and quickly tell me the ID number, NIC number. Yes. Professional qualifications. Yeah, so educational qualifications, then about professional qualifications. Yes. Yeah, so relatable. Yeah, when it comes to you or the working place, the workplace. Yes, email ID. So yeah, the DO. Hi. We are not selecting student for nursery. Fine. Okay. Next is weight. Yeah. Okay. Maybe not that much relatable, but okay, fine. Yes. Signature. Oh, good. Then we can falsely use them. Good, very good. E-signatures, okay. Address K. Okay. So workplace we are saving, delete the workplace address being saved. Fine.
Workplace contact number.
Yeah, so you had heard me. No. Yes, could be an image, the photograph, an image could be photo. Yeah, then I can know who you are. Hey, then from that now, only the faces I know can't relate with the name. I still know only one. Yes. Okay, we have the contact number and the WhatsApp number. Fine. Family member details. Okay, yeah, could be definitely family members. Or if we like, we can put it mother, father, yes, family members. Yes. So we are getting okay. Account details could be.
Academic subjects.
Yeah. So could be the relevant subjects. Courses could be years.
Gender.
Gender told, but you were saying something else. Yeah, I told okay.
Another contact number. Emergency contact number.
Okay, so we have the contact number, WhatsApp number, and the emergency contact number. Okay, fine. Yes. Yeah.
LinkedIn.
Facebook. Oh, yeah. The different answers coming. So we have the FBID, and yes, even the LinkedIn. Okay, so LinkedIn. Okay, you have helped to that. Good. Yes. So yes.
Blood type.
Yeah, definitely. Blood type. B. Blood group. Yes. NSCS, yeah. So yeah, running an hospital. Allergy. No, but those are needed. Even students definitely need it. Yeah. Yeah, family members. Okay, parents. We have added here. Fine. Yes. Nationality, yeah. So now we do not bother about these things, neither. Even for our CVs, like even we are not adding. But yeah, no anybody we can. So we have an address, workplace address, and a permanent address. Postal address, okay. Fine. And civil status, okay. Yeah, so for you all this is applicable, not for our normal students. Right, so we can see, right, we may be thinking, okay, whether there are information to say about this data or the student. Yes, we add. So student is going to be the entity. Yes. Yes, so online students, can you add anything? Hope the mic is on. Just for anyone can add any attributes related to the students.
Emergency contact numbers.
It's connected, right? Only few are there today. Yes, Chandrakanti, are you there?
Yes, ma'am.
Yes, any attributes for student?
Contact numbers.
We can't hear you. Numbers. Yes, Chandrakanti, sorry, can you please repeat again?
Contact numbers.
Yes, so we have the contact numbers, could be the emergency numbers, the WhatsApp related numbers. Yes, so hope you all get the idea. Yeah, So for a student entity, here's these various attributes, we will be able to have them. So likewise, we are going to have these different entities. So we are student. Similar we can have for a lecture. So again the needful information related to the lecture. Or maybe related to this different courses or different subjects courses. Yes, they could be an entity. Or as we said earlier, even a lecture or it could be. So whether we have the projector, whether we have the needful other facilities, how many seats, the capacity, those information, yes, definitely we could have. So likewise here, different entities as their relevant attributes. So each and every attribute is going to be the field, the different fields in the database. Then here, these different entities, now we know in the database, there should be a link. They need to get connected with each other. So that's what we will be checking in the next one, the relationship between these entities. So that also we will be mentioning there. So the entities will be there, then the needful attributes, and how these entities are getting connected, linked with each other. So that's what we will be referring as the association or the relationship. So once we draw and get to know about many entities, we'll see how these entities will be getting connected with each other. Right. So the first function or a usage of the DBMS is creating database. So let's see how we can create a database. So yeah, there are 5 steps. So first we will be doing the data plan. So maybe for SAT, we are going to create a database. So what first we need to do, we need to get to know what's happening in SAT. Or maybe what other processes we start from the registration, it could be even from the marketing, the registration and this activity related ones, exams related one, financial related one. So all the processes, what's happening in the organization, we will be getting to know. Then we can identify, okay, these are the things happening and these are the people getting involved. We will be getting to know, we will be able to get to know an idea. Then we will be moving to the requirement specification. So yeah, there is several different activities are happening, but when it comes to the needful in order to develop a database, maybe all the information, all the data we don't need to include. So now we take the decision or we will be getting to know what is our data requirement. So maybe from that end we can find, or maybe the other end, from the information. So we can find what information is needed in our organization. Then we can come from that, okay, in order to generate this information, what data we will be needing. So that will be our third step in order to get to know what data we are needing, or maybe what information we are going to generate. In order to generate this information, what data we will be needing. So now we have finalized, okay, these are the data we need. Then we will be moving to the third one. We will be creating a conceptual design. So now still we have not started to develop the database. We are doing the homework. So the background work we are doing. So now we know what data we need. Now we are going to draw, or we will be designing a conceptual design, a concept. Okay, this is how our database is going to be. So in this process, so in the third step, in the conceptual design, in order to draw the conceptual design, we will be drawing a diagram. So we will be drawing a model. Can you identify the name? What will be these models' name? So in the conceptual design, in the third step, we will be coming up with the model. What could be that model's name? Yes? What model we are going to come up with? Yes. Yeah. Okay. Anyone? Able to find the model's name? course name. Yes. So the answer is there. That's why I'm asking. The third step. The third step. It's the fourth step. So we are in the third step. Yes, correct. High level model is there. So for this high level model, there's a name, specific name, correct. High level model. There's a specific name. Really? We can see this. Using the color. Yes. High level model, correct. Specific name. So we were talking about entities, right? So we say in a database there are entities. What it should be? Yes, correct. So it's going to be the entity relationship model. So the answer is there, right? Well, third කිව්වම මේක විතරම බැලුවේ. So this is also relatable to the third one, this box too. So we have two boxes for each, right? So here we have, yes, the eye level model, correct. That is going to be the entity relationship model, because in a database we have entity and we are saying all these entities, yes, they have the attributes and they should be relatable with each and every other entity, because there could not be any separate data. The data needs to be linked. So yes, we will be drawing an ER diagram, entity relationship diagram. That will be a conceptual design to get an idea. This is how our database is going to come up with. So let's assume maybe a database here. So we have the student. So if it's an entity, what we do in the ER diagram, we have to show it in a rectangular. So in a rectangular, if we are showing, it will be an entity. Then yes, we know there are many attributes. So we take few, maybe the name, then the registration number, maybe the DOB, right? Few things are there. So in an ER diagram, if we are showing the attributes, yes, this is how we are going to show them. In an oval shape or in a circle, we will be adding them and we have to connect it with the particular entity. So let's take there is another entity relevant to the course. So all the different subjects, yes, it's going to be a separate entity. So any attributes can you come up with? Yes, any attributes for course? If it's course, what details we may have to say and keep? The name, yes. So course is this, we are talking about the subject. So M- is the course, right? So the name, yes. Code, the course code, yes, maybe the course code. Level, yeah. So in which semester, like, yeah. So the level. So few details we have kept. And just let's assume we have another entity, lecturer. Yes, so for lecturer, any attributes? Name. The subjects, yes. මගේ නම විතරක් ඇති නේද? නැත්නම් height weight එක දාන්න කියලා ඔයාලගේ නාන්නේ නැහැ. Yeah. So maybe we'll say an ID number. We have an ID number. Could be the qualifications. Yeah. So some details we have. So entities and their relevant attributes we have. Right. So we know in the database we have the entities, attributes, and their relationship, how they are getting connected. So if we take the student and the course or the subject, how you are getting connected with the course subject? How you are related to a course? because you are studying the particular course. So English course, are you related here in the set? For English course, business communication, no, because you are not enrolling in that, or you are not studying that course. So only the relevant courses, there could be a lot, but only the courses which students are, how they are going to get related, if they are studying, or maybe we can say a nice word, enroll. So that we will be showing in an ER diagram. So we are saying enroll like in a diamond, and we have to connect them. So student will be getting enrolled in a course. So this is going to be the relationship between them. So if it comes to lecturer and the course, how the lecturer and course may be getting related? So am I related with business finance? Then yes, again I may be needing to, or the lecturer may need to teach. So yes, we can say lecturer will be teaching. So teach the course. So this is how we are getting related. Right. So whether students and lecturers are related. So we are associating. Yes. Then what we can say there? Or do we need to show it there? No. Why? Not to mention relationship. Yeah, correct. So why we say if we need to find okay the lecturer who are the relatable students, what we can do, we can go through this path. We will be going and finding what are the courses we are teaching. Then that particular courses who are the students are related. So there is a link. We don't need to add here again. Some many other link we no need to add. So no need, because why? There is a link. Or even for the students, who are the lecturers of these students, if we need to get to know what we will be doing, we will be going and finding what are the courses the students are enrolled. Then from there we can identify who are the lecturers. So from that we will be able to identify who are the lecturers of this particular student. Because database, there is going to be many data, many entities, attributes. So as much as possible, we have to try to keep it in a simple way. So we should not make it complicated. As much as possible, the relationships we have to reduce them. So this will be a very small ERB with just 3 entities and their relevant attributes and 2 relationships. So now you may have got the idea. When we are adding a relationship, there should be a verb, action verb we should be mentioning. And a small one. So student lecturers are teaching the courses, no need to add teach, or maybe the end. So likewise an action verb will be added. And one more thing we can see here in the relationship, there are 3 types of relationship. So we are referring them as one-to-one, one-to-many, then many-to-many. One-to-one, one-to-many, many-to-many. So let's see how we can add it here. Right. So if we see student and course, what type of a relationship we have. So we are taking one student. So when we are considering one student, so can you tell me how many courses a student can enroll? One or many at a time?
One.
A student, how many courses they can study?
Many.
So in this level, how many courses you are studying only in my yes? 4, 5 you are studying. So that means a student can get enrolled in many courses in MIS, BF, all the lecture, the different courses they can. So we are saying one student, they can get enrolled in many courses. Right. Then we are coming the other way. We are taking one course. So if we take MIS, so whether only one student will be there or many students will be there. Many students are going to be, so this is also going to be many. So this will be a relationship of many to many. So always we are checking from one student, how many courses, one course, how many students could be there. So if we come here, lecturer and course. So if we take one lecturer, how many courses they can teach? So we think I'm teaching only MIS. So Charit sir is teaching only one subject. Many, right? So we actually take one lecturer, they can teach many courses. So this is going to be many. If we take one course, how many lecturers can teach that? One. Always one? Yeah, it's going to depend on the organization. So that we should be doing. So that's why we have to do that data planning. What is our process? So in some institutions here, one course, only one lecturer will be teaching. But in some institutions, it could be one course or same MIS, but two lecturers in a combined way could be teaching. So that in order to get to know what type of a relationship, so this depends. Could be one or even sometimes could be many. So that's why the data planning is important to get to know the process, how the things happening in the organization. Then yes, accordingly, we can put them here. So one course lecturer could teach many courses, and at the same time the course also sometimes accordingly could be one lecturer or many lecturers also teaching them. So this is a very small ER diagram with three entities, then with two relationships and the relevant attributes, and just the relationship types also. So are you all now confident to draw ER diagrams? So I can ask the question in the exam paper, right? So get ready to draw ER diagram. We'll see if we get the time, we'll try to draw an ER diagram and see. Right. So after we come up with this conceptual design, now we are moving to the logical design. So that means we have to select what type of a database we are going to develop. So there are different examples. Maybe we can get take the decision whether we are going to develop a relational database, or maybe an hierarchical database, or maybe an object-oriented database, or maybe a network database, or maybe a multi-dimensional database. So these different logical designs are there. That means what structure, or maybe what type of a database we are going to design. So that we will be selecting in our logical design. Then at the end only what we are going to do, we are going to sit in front of a DBMS and start developing our database. So that is going to be our last step, the physical design. So maybe in an Access, or in an Oracle, or in an SQL, MySQL, we will be start developing the database. So it's going to be the physical design. So this ER diagram or the conceptual design will be a backbone in order to develop the database, because we know here we can check whether we have included all the needful data, even all the attributes whether we have included, and whether we have mentioned the relationships, the connections in the proper way, or maybe one entity is there which is not connected with any other entity. So all these things we can identify here, we can double check here, and we can correct it in order to add some data or to add the attributes or to check the relationships whether they are correct. Then taking this as a blueprint, ER diagram, in the fifth step, we will be able to develop the database. So that is going to be the physical design. So this is the very first step in the DBMS, or maybe the applications of the DBMS, creating the database. And with that, what we can do, we can create the database application also. That means the interface, maybe a form to update the data, or to report, to retrieve the data. So these interfaces which we see in the form, those also we are developing using the DBMS. So the database, the backend we can develop, then the front end interfaces also we will be able to develop using the DBMS. Right. So these two together create function. What is the second function of a DBMS? Maintain. Right. So now we have already created with the very first step even the data we have added. But just we know the database or the data needs to be or will be getting updated. So like the email address getting changed. So now what we will be doing? Yes, the needful changes, so maybe to update them, or if there are some changes, so maybe now we think, okay, one attribute now we have to add, so maybe we have forgot, or maybe a new attribute came, so we have to add it. Yes, we will be able to update, or if we need to remove those things, so those changes also we will be able to do using the DBMS. So it's going to be the maintenance part. Then what is the third one? Integration or using the database. So now this is going to be kind of the major one, or the main use of this DBMS. Because why? We created the database and now we have saved and kept the database. Now we need the data back in order to generate the needful information. So now that we will be doing using this database integration. So here maybe no any big programming language, those things needed in order to talk with the database or to ask the questions from the database. So there's this language which we call SQL. So what could be SQL? Any idea what you know? Yes. Structured query language. So we are referring it as the structured query language because we are going to write query. So that means small steps we have to write in order to get the needful data from the database. So we will be using this SQL, the structured query language, with logical operators. So what are the logical operators you are aware of? Logical operators? Logic gate same with yeah, and or not. Yeah, could be. So these logical operators. So with that, even very basic logical operators are there. Even in a keyboard, some logical operators are there. What are the logical operators we have? Yes. If here's the condition, yes. So in your keyboards, there are some logical operators. Check the lucky and O yes, any logical operator. Correct. So the basics which we have in our keyboards, the and don't have a keyboard again. But 2, 3 very basic ones are there.
Equation.
Could be the equation in order to make it equal. Yes, that could be considered as a logical operator. Smileys. So those are smileys, not the operator. What are the operators? Yes, could be the slash, yeah. Oh, they got clear on it, but we're not those are arithmetic operators. The logic. Function. The functions. And okay, yes, correct. Could be okay. But very basic two are there. Only keyboards for that. My name is Indra. Oh yeah, it's there. I got confused at the time here. Plus minus arithmetic operators. We are which we will be doing the calculations here. So we are calculating arithmetic. So haven't you seen these two operators? Maybe the keyboard we are not mainly using them. Do we have? What are they? So greater than, less than operator. Anyone? So yes, we have the logical operator. So starting from and or between or could be conditions also. And with this, even the basic operators equal or greater than, less than. Using the SQL, we will be able to write the queries whenever needed or whatever data we need. And just accordingly to develop the in order to get the data from the database. So let's see, we will try to write a very small query using the SQL.
Excuse me, madam.
Yes.
Madam, we can't see the whiteboard which you have written.
Yeah, I'm sorry, I will. That try to focus it. Hope it's okay. Yeah, so anyhow, I will add a ER diagram to your LMS. So maybe a similar one I will draw an update to the LMS because I think it's not that much visible to our online students. Yeah, so after the class, definitely I will upload. I will just go with the soft copy and I will upload. You can double check. Yeah. Right. Sorry, fine. So, yes, about the queries. Right, so let's see how we will be able to write a very small query. So maybe let's take the same data. So let's assume this is going to be our database. So the same ER diagram with the entities data we have developed our physical design. So now we are going to get some data. So very simple. I need a report or I need information of all the student details. So very small report. So what we will be doing? Yes, I will be coming with search. So this is going to be a SQL keyword search. So I'm going to search the name, registration number of the student. So I just need a list. So maybe I'm going to mark your presentation. So I need a list. So I'm going to search the name and the registration number. So there could be, so if we take the name, even the lecturer also there is a field relevant to the name. So we have to specifically say from where I need this name. So that will be our second keyword, from. So it's again an SQL keyword. So we are saying from which entity we have to mention. So we can say from student. So here we may have mentioned the entity's name as student. So we are saying here search the name and the registration number from student. So this is going to be a very simple, very small SQL query. So So what could be our outcome? Yes, maybe in a table, we will be getting the names and the registration numbers. So this will be our outcome. So very small query we could use. Name, so search from. Those are going to be the keywords which we are using. So with the other relevant attributes, we are going to use them. And when we are writing these queries, we have to make sure the names which we are using, the field names or the entity names, they should be similar to what we have in the database. So here we have attached the registration number. And if I'm going to add on like ID number, yes, it's not going to work. So we should be knowing the same exact words, yes, in the proper way we have to use. So it's going to be a very basic query. So there could be another keyword. Maybe we can little bit advance our query. So let's assume here we have your attendance also. So as a attribute, we are adding your attendance. So now here, the examination needs to get the list of the students who have attendance greater than 80%. Then only they can give you the exam admission cards they can give. Okay, so they need to find. So now not be all the entire list of the students, only the students who have greater than 80% attendance. So yes, we are having an attribute. Fine. So now it's going to be the same. Search, name and the registration number from student. And now we are going to add a condition. So we say it as where. So where, yes, again an SQL keyword. So it's going to be the condition. So we are saying where attendance. So we know we have studied these logical operators. Here's what we can say: attendance greater than 80%. We can give a value there. Then what will happen? Here's all the attendance details are there. But the DBMS will go and analyze and see. And in the student entity, yes, name and the registration number, but not the full list. Only the students who are having attendance greater than 80, only their name list will be printed now. Or likewise, we will be able. So this is a little bit of a with the 3 steps. So earlier with only 2 basic functions. Now just with the 3, we will be able to. So this search, from, where are the keywords of the SQL. So that's why when we are writing, usually we are writing in the caps. So the capital letters we will be writing, we are writing. And just with the other fields, so the attributes, relevant attributes we can use. So this is the very basic one. And we are getting the data only from one entity. Likewise, we can combine and get. So as we earlier said, what are the students, maybe the particular students, what are the courses they are studying. Then we can join 2-3 tables, so the 2-3 entities we can join and get the information. So all our reports, this very good analysis information, how they are happening, here's through this queries. So we have saved and get the data there. Then once we write these queries at once linking different entities or the attributes with the different conditions, yes, we will be able to come up with the needful information. But just you get to know SQL is there, and yes, we will be using this language SQL with the different logical operators in order to retrieve the data back and to use them. So this will be the main 3 functions of a DBMS. So we can create the database and the interfaces, and yes, we are able to maintain the database, and we can use the data also through the database. Right. So shall we try to draw a ER diagram? So you need a break? Okay, then maybe quick break, 10 minutes. Oh yeah, good. Then a 10 minutes break. Because we have to try to cover it. Yes, then we meet in 10 minutes.
Excuse me, madam.
Yes.
Madam, if you can you explain which you have written on the whiteboard? Because we didn't see how it flow. What's the flow is?
The ER diagram or the queries now we are studying?
Which you have written on the diagram which you have already written on the board?
Yeah, sorry, yes. Yeah, I'm not sure whether the whiteboard is visible. Is that okay? The focus to the whiteboard?
Yes, madam. Okay.
Yeah, I will then go through it again. So you guys are going to get repeated. Is that fine? Yes, so that diagram actually we came with this one in the database development. So yes, we have the data planning. So we will be getting to know the current processes in the organization. Then we move to the requirement specification in order to get to know, okay, what data, the specific data we need to save and keep in a database. Then we are moving to the conceptual design. There only we were drawing this diagram, the ER diagram, entity relationship diagram, or the ER model. So we know in the database there are these entities, attributes, and the relationship. So those what we are going to show. So let's take student as an entity. So if we consider student, yes, it will be an entity. So we will be showing it in a rectangle. And the relevant attributes, so earlier we were discussing, could be the student name, the student registration number. Likewise, the relevant attributes we will be adding there. So it could be the name, or could be the registration number, or maybe the contact number. Likewise, the needful information, the attributes we are adding. So those we are showing in this oval shape. So in the oval shapes we are showing, and we have to connect them with the entity. So likewise, student, one entity. Then yes, we can have another entity, course. So course could be another entity. So again it goes in a rectangular. Then the relevant attributes, that means the properties of the course. So maybe the course name. So it's going to be an attribute. So we are showing it in an oval shape. And could be the code, course code. Yes, we are showing. Or maybe the level or the credit numbers. Likewise, the relevant attributes, the properties, yes, we are showing them. Then yes, we said there's another entity, lecturer. So relevant to the lecturer, yes, we can have an entity. Again, the relevant attributes. So entity is in a rectangular. Then the relevant attributes, yes, we are showing them in oval shape. So maybe the lecturer name, maybe an ID number, or maybe the qualifications, like we are showing the relevant attribute of this entity. Then we know in the database the entities, they need to be connected, linked with each other, or that is what here we mentioned, the relationship. So how we can say the relationship? Yeah, the student and the course. So how they are going to get related with each other, the student and the course. So maybe the association or the relationship between them could be enrolled. So once a student is enrolling in a course, that is their relationship. So if we will be showing the relationships, yes, in a diamond shape, and we are going to connect them. So in a diamond shape, we will be connecting the needful two entities. Same with the lecturer and the course. So how the lecturer and the course are going to get connected. So we can say maybe teaching. So lecturer will be teaching the course. So that is the association between them. So again, in a diamond shape, we are showing and we are connecting them. So this is a very basic ERD, entity relationship diagram, with three entities and their relevant attributes and how they are getting connected with each other. So with this we were adding another one also, the relationship types. How does these two entities are getting connected with each other? So there are three relationship types. We are calling them one-to-one, one-to-many, and many-to-many. So these will be the three relationship types. So that also we can see. Okay, so let's see how the student and the course. Enroll is the relationship, but how they are going to get connected. So we will be taking one student. Okay, so one student at a time. How many courses they can get enrolled? So how many courses? Yes?
Can be one or yeah, can be one or more.
More, right? Yeah, definitely. So in the same time, you are studying 5 courses together. So one student can get enrolled in many courses. So we will be mentioning an M there, many. Then the same time the other way. If we take one course, so if we take this MIS, how many students can get enrolled? One
Many.
or many? Many,
Many.
yeah. So it's also going to be many. So this relationship, we can say it is a many to many relationship. So same with the lecturer and the course also we can check the same. Okay, so we are taking one lecturer, then one lecturer, how many courses they can teach? Yes?
Many.
If we take many, right? Yeah, so one lecturer will be teaching many courses. So it's going to be many from the course side. Then here's one course. If we take one particular course, how many lecturers could teach that?
One or many.
Yeah, that also could be. So that depends. So sometimes could be one lecturer, or maybe some institutions, even the same one course, 2-3 lecturers together will be teaching. So that depends on the process or the normal activities of the organization. So it could be a one, sometimes some institutions, be a one-to-many relationship because only one course, one lecturer. But in some institutions, it could be many-to-many because one course, many lecturers could be teaching. So this is what we were looking in the ERD. So we have three entities: student, course, and lecturer. And to relate them, yes, we have enroll, student enroll in course, then the lecturer teach course. So that is the relationship. And just we are able to show the relationship types also. So this is the ERB tutor. Anyhow, I will update a soft copy also to the LMS later on. So you can get the idea and double check the ERB. Is that okay?
Yes, madam. Thank you very much.
Minutes went. Lamani method. No, I gave it 3. That's all. Okay. We start it. So you are promised to draw an ear diagram. Are you ready? Can you draw an ear? small one. So find the entities and their relevant attributes. Find the RPK. We are focusing on the data. What will be entity and one. So something relevant to here we did for student post lecturer. So likewise, how these data could get connected with each other. So we will be finding the entities, their relevant attributes, and how they are getting related. Okay, correct. But you say like we want action verb that we are using. If we can pick one action verb, how we order yeah, we can say base order. So again, base the order on the case. We have to pick base order. Only one action, two actions. Just base this. Customer base order. That is order and products. Even from here you can see the action. Planning to give you a ERP question in the exam. Okay, right? Yes. So anyone wishes to come and explain these answers? Anyone ready? Can you? Why? So just draw it and explain it for us. Explain correctly after 5 marks adding. Need 5 marks? No. You need 5 marks. Yeah. Almost we have got 40, 45, 35. To make it 50. I think we reduce marks. Those one are coming from 5 marks reduce. Definitely I'm going to do 1 mark reduction. Now 5 marks here, add 1 mark. Fine. Thank you. Can you? 5 marks or 1 mark reduction? I'm okay to 5 marks, I will be taking. Can you? Right, so as the time is going on, I'm going to. Okay, so but definitely 1 marks reduction. Yeah, but definitely you can get the support. Can't help with the 5 marks. Sorry, grown. So yes, the next person to explain. Yes. Yeah. Who's going to explain it now? Any volunteers?
The customer is an entity, so it has the attributes of the name, ID number, and the status.
Yeah, so better to put the status also separate on it. Yeah, correct. Yeah, good. Keep on.
Then the customer and the order will be interconnected by placing the order. So that's the relationship. Then again, the order can be treated as a separate entity. It has its individual attributes like order number and the address. Then the order and the product. Product is another entity. So those two would be interconnected to the delivery because the order product should be delivered. So the product has its own attributes as the product code and the description.
Good. So it's a contribution, right? One person of 5 marks, as it's a contributed, I will add 1 mark. For those who are presented here today only. Yeah. So you all sign? Only you all sign? Not bad. How many are here? Can you just check the signs and can you check how many are here? Because only those who presented, yes, I will definitely add 1 mark. Those who are here. And yes, the online also. I will get the attendance. Okay, so yes, as Pavani correctly explained, customers placing the orders, then the orders may be having so delivery, or maybe directly from here we can pick a word, include. So delivery is also fine. Or maybe directly from there we can pick a word, order includes the product. So what are the products? Yes, we have one. So yes, correct. So hope everyone is fine with that. So kind of a similar small ER, you should be able to draw. So everyone fine, okay? How many? 29. How many students are here? You already signed? Okay. Make sure not only you are signing. Then we will quickly move to the rest. Yeah. About the distributed databases. So these are also databases. Separate or maybe a different kind of database. So we usually know when we say database in one place, we are going to save and keep all the data. So yes, it's true. But sometimes, according to our need, we may have to distribute our database. So maybe it could be a big company, so they are in different branches. So what could happen in their head office? Yes, they have the database. But to their branches, so maybe to the academy, to the college, to the JAFNA, when they are in different branches, they may be distributing their database. So in two ways they can do. Sometimes a copy they will be distributing. So in the head office also they have a main master database. Then the same copy they will be distributing to their other branches too. Else, a part they could distribute. So in the head office, the master database is there, and maybe in the candy branch, only the needful part. So all the other JAFNA data, goal data is no needed. So only the needful parts of this candy branch, that part they can copy it to there. Likewise, the other branches also they can do. If we are doing like that, we are finding as a distributed database. And what will be the main advantage? The production of the data, because in case one person is going to mistakenly delete the data or something, still our master database will be there. So main advantage the production, and it will be easy to this local site. So once we have distributed a part to maybe to the candy site, yeah, they will be analyzing, they will be doing their job. So even when it comes to the processing, it will be more efficient because only their data they will be added. That's what will happen from this big database, they have to retrieve the full data. But now only their part is there, so it's easy to analyze. So to do the process in an easiest way, in a quicker way, they will be able to do. So this will be the kind of advantages. But again, there will be a disadvantage because why the data is getting duplicated. So if the data is getting duplicated, all these maintaining the data or updating issues, accuracy issues, all could happen. So that issue is also there. But according to the need, there are some organizations may be distributing their databases. So just you need to know there is this distributed databases also. Right. So this time we were talking about databases. Now we are going to move into the next concept, data warehouse. So different files together we come up with the database. And now what we are going to do? If we have different databases, all those data we are going to collect and put it to a final place. That is going to be the data warehouse. So maybe in an organization there could be 2-3 databases, could be so customer related database, or maybe the employees related database. Likewise, there could be. Then what we are going to do now, all these different databases, we are going to collect all this data together and add it in one place. But if we are using different systems, so through the ERP system, to the system we will be having a database. To our CRM we will be having a database. In CF we will be having a database. So now all these databases, all these data, we are going to consolidate it. We are going to gather and keep it in one place. So this is going to be the final destination of our data. So before storing, saving the data there, we have to make sure the data is clean. So that means no any missing data, no any inaccurate data. So all the things we have to check, and in a standardized format, we will be saving the data there in the data warehouse. So what will be the main advantage? Databases there, that's good. But again, while we are moving to data warehouse, so have you heard this word data mining? Heard? Yes, right. So data mining. So what we will be doing in a normal mining thing, once we dig and go inside the solid, or what we will be able to find, yeah, these important or valuable gold, diamonds we are finding. Same here in the data mining. Once we dig and go, that means once we analyze deeper and deeper in the data, we will be able to identify valuable information. Maybe some trends, some behaviors we will be able to identify. So in order to do that, a little amount of data is not enough. So if we are going to even in a class, so if we are going to check how the students are behaving in the class. So only if I take one class, only today's class, and if I take a decision, all students are like this, students are coming in front and they are explaining the thing, will it be a valid finding? Maybe not, maybe, and then in order to take this conclusion, so in order to even to generate the information. So in order to take this valuable, more important information to generate, that's why we need a big set of data or history data we need, or data linked with all the other different processes needed. That's why we are moving to the data warehouse, or data mining, or to the analysis purposes, research purposes. Now, rather than a database, bigger version, data warehouse, we can use that. Fine. So from databases, we got all the data and put it in a data warehouse. But again, if the data is there in all the data together, again it's going to be hard to work on it. So now what we are doing, the data warehouse, we are going to divide them into data marts. Again, we are going to kind of put them into different subsets. So rather than having all the data in one place, we are going to divide them into different subsets. So this diagram gives you an idea. Yes, from various databases, from various application systems, from ERP, inventory, logistics, yes, we are getting the data. So different databases. So they all go to the data warehouse. But later what we are going to do, we are going to divide them into subsets. So all the finance related data in one place, all the marketing, sales related data. So for the data mart, data may come from these various databases. So from ERP, finance related data may go there. And even inventory, yes, could be finance related data, could be there. Kind of the logistics, shipping, purchasing. So all the data where we have created to the finance now in one place. So now it's easy to do our analysis in a more depth way, or maybe in a more specific way. Rather than general analysis, specific analysis we will be able to do, and this depth analysis we will be able to do. So that's what happens here. From the databases to the data warehouse, and we are moving to the data mart. So this is all about the databases. So we got to know what these databases are. Before that, traditional style approaching was there, the issues we were discussing. Then we moved to the database, and we were discussing about the DBMS, the database management system, and the functions that we can create, we can maintain, and we can use the database. So in between, you should be knowing about the diagrams a little bit. And just we came with the distributed database and the data warehouse. So it's the end for our database lesson and for our MIS lesson also. So meantime, do you have any questions? Yes? No questions. Good. So your lectures are finishing? No, you have other subjects are there. So yeah, before the exams, you are getting a big break for MIS. What we learned in the MIS. So you should be knowing. So you can go through the past papers, but past papers are for our students. For students, I mean for our small kids, but you are big kids. So little bit different means little bit advanced will be there. So rather than asking direct questions, kind of to explain relatable questions will be there. Direct questions also there, but it will be like the case study. Case studies karaga. Oh, okay, anything. So just go through the case studies, then you get the idea how the questions will be there. So not maybe directly asking the question, but direct ones also will be there. So definitely you all can get the 40 marks. It is no any issue, but you have to write. Something you have to write. Therefore, the blank papers, pages, I can't give marks. So you have to write something, then definitely you can get a 40 marks. Definitely you will be able to do. But if you need to go for A+, A minus, then yeah, little bit more you have to write. But I think already you have got the very good marks. I think almost everyone got the very good marks in your CA. So in case if there are any issues with the CA marks, let me know. We got an issue sorted out. So any issues if you find in CA, let me know so we can use anything. We can adjust. So already you have got more than 30. I think everyone have got more than 30. So another 30, 47 unknown. Then definitely you will be able to get very good results here. Yes, anything from your end to ask? Any queries? also joining with the normal classes, so that's why we have the exemption. For the new syllabus, you only pay batch, the new batch the exemption. So only exemption students for teaching to big kids. Yeah, it's a good experience to meet you. Had a good time with you all. So we hope I'm not sure whether we will be having any more classes together, but anyhow you will be here. I will also will be here, so we can meet. So good luck for your exams. Do good in MIS. Get A's, plus A's. Okay. And here, so God bless you all. We will see you. So yes, visual side. And you all right. I will add the one.